Hey guys, today we will discuss about ocean control system. So we will discuss about the ocean control system. Does anyone knows what is ocean control system, guys? So ocean control system. So in this we need to know need of ocean control system, how ocean control system will work, the basic terminology of a ocean control system, benefits of ocean control system, types of ocean control systems. So centralized ocean control system and distributed ocean control system. So ocean control system is also known as software configuration management or source code management tool. So what is that, guys? Management Source code management tool. So I will tell you, guys, I will tell you, no worries. Source code manage source code management tool. So what is this source code management tool? So where we can use this source code management tool, right, guys? Yeah, so developers, right? Developers are working on the projects. For example, so developers are working on the Facebook or a WhatsApp project. So what is that? A Facebook or a WhatsApp application. So what is that project name is? Project name is like a WhatsApp application. So WhatsApp application. So what they are doing, guys? They are doing the what they are doing. They are developing the programs, right? They are developing the programs for the application. So once they developed the programs, they will they will push it to the some other place, right? So that is a repository. They will push it to the some other place. So the place is call it as a repository. So where the data, the developers data, the developers code pushed. So the developers code will push it to the push it to the repository, right? The data will be pushed to the repository. So repository. So repository where our code will be there. All the programs information will be available in this repository. So in this repository. So this is called as a source code management tool. So So your code will be available in this repository. So who will manage this repository? Who will manage the source code management tool. So we have a source code management tools are there. The tools will manage these codes. So who will manage, guys? So the source code management tools. So what are the source code management tools are there? So we have a two types of source code management tools. So one is a CVCS and the other one is a DVCS. So what is that, guys? CVCS and DVCS. So what is CVCS and what is a DVCS? DVCS. So what is CVCS? CVCS is nothing but a centralized centralized ocean control system. Centralized ocean control system. And what is DVCS? Distributed ocean control system. Distributed ocean control system. So DVCS is a distributed version control systems, and CVCS is nothing but a centralized version control system. So what is DVCS and what is CVCS? CVCS is nothing but a centralized version control system and DVCS is nothing but a distributed version control system. So nowadays we are using the a distributed version control system. All the companies are using all the companies are using all the companies are using the DVCS. So DVCS means distributed version control system. So Git. Examples are Git, guys. So CVCS examples are something like SVN, So SVN is one of the subversion. So subversion is the one of the tool. Subversion control system. This is the one of the example of the CVS, and DVCS is one of the example of Git. So what is the drawbacks of CVCS? So what is the advantage of DVCS? So I will discuss, guys. I will discuss. Yeah. So for example, being a developer. So guys, being a developer, we have to write. We have to write the several files like a programs which contains, so which contains the source code, which contains the source code, right? Source code. So developer, what developer is doing? Developer write the code. Developer write the code like a files, right? So where he can store in the repository. So we can store in the repository. So for example, client gave a requirement to some other tech world with Hari to develop a project. So to develop a project, so something like a client project, so 100 files, 100 programs created, 100 files are developed. Client suggested to some changes. So already developed, but the client suggested some changes. So the changed some files some files source code to meet the client requirement. So I gave a demo to, and client suggested some other changes. So I changed the some other file source code. So source files to meet the client requirement. I gave a demo third time. Client asked for a first version only. So my so my face with big. So what is the first version? I created, right? I created and I modified, created, modified, created, modified. But client wants a, so client is interested on the wherever we firstly developed, right? That code is he is interested. But we modified the files, right? So we modified the files for the client requirement. So the initial files will not available, right? So I want the first files also. So I want the first file. We should not overwrite the code. So every version we have to maintain. So every version we have to maintain. For example, so first code, modified code. So modified code, guys. So modified code, and again modified the code. So whatever the first code, right? I cannot see it because of we modified it, again we modified it. So we want that code also. We want that code also. We should not overwrite our code. Every version we have to maintain. Every version we have to maintain. So maintaining multiple versions manually is very complex activity, right, guys? So maintaining multiple versions manually is very complex activity. Something like dev A, dev B, working on the code. At least we have to merge the code developed by both developers, and we have to deliver the client. If both developers developed the file and named with that, then the copy will overwrite to another copy, which creates a abnormal behavior. So we should not overwrite the code. We should not overwrite the code. Something like we will create a one version 1.0 here. So again we will create another version 2.0. So 2.0 contains this code, and version 3.0 contains this code, modified codes, right? So whenever client wants a first code, so we will go to this version, and we will get the code. So we will go to this version, and we will get the code. That purpose we are using the version control system. So that purpose, so we are using the version control system. Now you understood? Every change should be tracked, like who did the change, when he did the change, which changes are did he. We want all the changes, which we want to all the changes should be maintained. We want to all the changes all the changes should all the changes should be maintained, right? So maintained, how you can maintain the all the code, all the changes. So overwriting of the code should not be happened. So developers have to share their code to peer the developers so that multiple developers will work on the collaborative way, right? Parallel development must require a, so something like some other guys are working on this project, some other guys are working on another project. So we'll create the versions. How version control system will work, guys? So how version control system will work? Version control system. So version control system, how version control system will work, guys? So version control system always talks about the files which contains a source code. So version control, yeah, guys. So version, how version controls, how version control system will, how version control system will work, guys? How version control system will work? So version control system, VCS, guys. VCS is nothing but a version control system. Always talks about files, which contain, so which contain source code, source source code, which contains VCS. Version control system always talks about files which contains the source code. So everyone required version control system to maintain different versions of their document, right? So something like a testers also there, architects also there, testers, so testers also, so testers are also working, developers are also working, right? So developers also working, architect also, project managers also working, project managers also, so project managers also working, and architect also, so architect also working on the working on their changes, right? So we need the track of all the codes. We need a track of all the source codes to maintain a different versions of the test scripts, to maintain a different versions of the documents, architect people, so project manager purpose to maintain a different versions of the Excel sheets. So everything will be, well, everything will be tracked under the version control system. Guys, understood? So everything will be tracked under the version control system. So for example, guys, so for example, you created a repository. So you created a repository. So for example, so this is the a repository. So this is a repository. In that repository, client app, so Java, E.Java, B.Java, C.Java. So this is our working directory. So this is our client app. So this is the CVS, for example. So you can commit to the centralized version control system. There is a version control system, and check out the code because of so people are more people are working, right? Once you commit, so you can the other people also commit to the code. So you want to check out, you can use the, you want to get the their code also, you can use the checkout. Their code also you can use the checkout. For example, C1 version 1, C2 version 2, C3 version 3. So you created a files, guys. You created the files. Now you understood the version control system, centralized version control system. So this is the a centralized version control system. So centralized version control system. So VCS. So centralized version control system. So you directly connect to the centralized version control system. So for example, if it is crashes, if it is if it is crashes, the entire data will lose. If you use the centralized version control system, what is the drawback? The centralized version control system, directly you can connect to the centralized version control system, and you can push your code, and you can commit, and you can check out. Commit is nothing but a pushing, checkout is nothing but a downloading. If centralized server goes down or something like it crashes, so the data will be lost. The data will be lost. That's the reason. So most of the people are moving from centralized version control system to distributed version control system. So why they are moving from centralized version control system to distributed version control system? Something like So so we can, so in the version control system, any version control system, either distributed or centralized, the benefits of version control system: commit message, and who did the changes, when he did the changes, what he did the changes, right? So multiple developers can scan, work, control anyway, parallel development, we can provide the access control, like we can read the code, we can modify the code, anything, right? So this is the benefits of version control system. So the types of version control systems are uh, centralized version control system and distributed version control system. So in the centralized version control system, so the name itself indicates that this is the type of, this type contains only the central repository, and and every developer should be connected to that repository. The total project code will be stored in the central repository. If four developers are there, still they have only one repository. If the four developers are there, still only we have one repository. So in that repository we can, so we can we can share, we can send the code. So we can send the code to the, yeah. So you'll see. So four developers are working. So developer workspace. So this is the central repository. So this is the central repository. Everyone can push their own and their code to the central repository only. Central repository only. This type of VCS is very easy to set up and use. This is very easy to set up and use. Even the examples of CVS, SVN, PUFOS, TFS, clear case, etc. These all are the centralized repositories. What are the centralized repositories, guys? The centralized repositories are CVS, SVN, and the PUFOS. So PUFOS and TFS and the clear case, and etc. and etc. So these all are the distributed, so centralized version control system. So centralized version control system. So what is the problem with centralized version control system? The problem with centralized repository is the only one place where everything will be stored. The only one place everything will be stored, which causes a single point of failures. Definitely, it causes a single point of failure. It causes a single point of failure. If something goes wrong to the central repository, then recovery is very difficult. What is that, guys? The recovery is very difficult. So very difficult. This is the one drawback of the centralized version control system. All commit and checkout operations should be performed perform performed by the connecting to the central repository via network. So these are the connecting via networking. Definitely, so it will connect via network, right? If the internet is slow, that definitely the performance will slow. The performance, so developer workspace and so remote repository server should be the connected always. So all commit and checkout operations should be performed by the connecting to the central repository via network. Hence these operations will become slow, because of, if your network will slow, definitely the performance will slow, which causes performance issues. So no local operations, and so and every operations will should remote operations. There is no remote operation, there is no local repository, right? So everything will be connected to the central server only. Everything will be connected to the central server, and commit and check out your code. So there must be a performance issues. These are the drawbacks. So organizations of the central repository is very complex. So very complex if number of developers and files increases. If number of files increases, for example, I worked on the SVN. So every time developer said, so I'm unable to push the code. It's showing something like a logout, or something like a, my internet is very slow. I'm pushing the code, so it's not stored in the centralized repository. So every time I'm facing the issues. I'm facing the issues. Developer every time facing the issues while sending the code to the a central repository. So we need a alternative solution. So what is that solution? The solution is called it as a distributed version control system. What is that, guys? A distributed version control system. So what is the distributed version control system, guys? The distributed version control system is Git. What is that, guys? Git. Who developed the Git? Who developed the who developed the Git, guys? Who developed the Git? Who developed the Linux, guys?
Linus Torvald.
Yes, very good. So who developed the Git? So who developed the Linux? So both Git and the Linux and Git developed by the Linus Linus Torvald. So Linus Torvald. So he released as a open source. So what is open source, guys? So what is open source? So open source contains two. So open source contains two. So one is free of cost. The second one is source code also available. Source code also available. If source code also available, right? So took that source code and created their own GUI tools. So who took that source code and created their own tools? I will show you, guys. Sorry, I want to save this, right? Yeah, save version VCS 2 new. So what is that, guys? Git. So what is that? Git. So Git is developed by the Linus Torvald and released as a open source. So the open source, right? Everyone took that source code, created their own type of Git tools. For example, so what are the Git tools created? So what are the Git tools, guys? So for example, does anyone knows? So it created it released as a open source, guys. Open source and released as a CLI. Released as a open source and CLI. Took that source code and so before it is some other company, now Microsoft. So Microsoft acquired the GitHub. What is that, guys? GitHub. So this is a GUI tool. So what is that, guys? GUI a tool. GUI Git tool. Who acquired, guys? Microsoft. GitLab. What is that, guys? GitLab. So GitLab also a GUI Git tool. So GUI Git tool and Bitbucket. What is that, guys? Bitbucket. So Bitbucket also a GUI tool. Atlassian. At Atlassian. So Atlassian company took that source code, Git source code and created their own Git GUI tool called as a Bitbucket. Guys, now you understood. So these all are the Git. So Git tools. These all are the remote repositories. These all are the remote repositories. So remote repositories. Now you understood, guys. So remote repositories. So everyone took that source code, and created their own tools. So what are those tools? GitHub. So what is this, guys? This is the GitHub. So GitHub is the distributed version control system. So we can store so we created a repositories. So for example, so AWS DevOps material is one of the repository. This repository contains the my material. Guys, now you understood? So we can store our data in the repository. So this is the Git repository. This is the Git repository. So this is the GitHub. The name is a GitHub. This is a GUI. So graphical user interface. This is also one type of a Git repository, right? GitHub, GitLab. So GitLab, GitLab. You guys. So this is the GitLab. So this is the GitLab is one of the other GUI repository, GitHub repository, Git repository. So the other one is Bitbucket. Bitbucket. Yeah, see guys, Atlassian company created Bitbucket, Bitbucket repository, Bitbucket repository. Guys, understood? So we can store your data. We can develop the code and push it to the either Bitbucket or GitLab or GitHub account, GitHub, right? So yeah. So what is a Git? Git is a distributed. So what is distributed means? So here there is a local repository. So this is the remote repositories. What it is? It is a remote repositories and local repositories. What is the local repository? So local repository. So whatever the developers, right? Developers develop that code. Developers develop that code and push it to the local repository. So developer develop that code and push it to the local repository first. So once push it to the local repository, then right. So a developer develop that code and so developer develop that code and so develop the code and push it to the local repository. So how they can push it? They can push it by using the add and commit. So add and commit. So through the add and commit, so they push it to the local repository. Now the code is available in the local repository and remote repository. For example, this is your code. This is your code. This is your code. So from the local repository to you are pushing. You are pushing. So you are pushing from the local repository to. So from the local repository to can push it to the remote repository. So remote repository and you can pull the code from remote repository to local repository. What this is, guys? This is a push. This is a pull. This is a pull. Guys, now you understood? So your code will be available under the your code will be available under the local repository and under the remote repository. Under the local repository and remote repository. If something goes wrong, on the local repository, right? So your code will be available under the remote repository. So once you can pull it, you can get the code again. Something like if remote repository is corrupted, so your code will be in the local repository. Now you understood the distributed version control system. Code will be distributed in different ways. Now you understood, guys. DVCS. Why DVCS is popular? So distributed version control system is popular because of the code will be available in local repository and the remote repository. The code will be available under the remote repository and local repository. So remote repository is nothing but a so So this is this is nothing but a remote repository. Your code will be in the remote repository. GitHub, right? GitHub.com. So this is nothing but a remote repository. So local repository, I will show you guys. No worries. No worries, you will understood. Right. So why DVCS popular than CVCS? So CVCS having only CVCS only. So only centralized server, we can directly push our code and we can push the code into the centralized version control system. There might be a issue with our network. Your code will be, there will be a performance issues, right? Yeah, source code management, the management of the code to the documents or computer programs or large websites and other applications of the information. The centralized version control system, we have only we have only one server, that is server. So whatever the working copy, right, you can commit and update, commit to push, commit to checkout, commit checkout. So but in the distributed version control system, so there is a repository, there is a local repository. So this is the a local repository. First you can send it to your local repository, then we can push and pull to the remote repositories, right? Your data will be available in two ways. One is in the local repository, the other way in the remote repository. If yes, if something goes wrong, so we can recover from either remote or we can recover from the either local repository, either local repository. Something like a source code management. Git is a distributed version control tool that support distributed non-linear workflows by providing the data assurance for developing quality software. So for example, so this is our working directory. So this is our working directory. This is local repository. So you created a project and you developed the code. You developed the code. You want to push it to the local repository. First, we need to know the local repository, right? If you want to know the local repository from your working directory to, you can push it to the staging area. So how you can push the data from working area to staging area? You can use the git add command. So from the git add command, so we can we can commit to the local repository from staging area to so local repository by using the git commit. So git commit, now your working untracked file will be tracked local repository. So from tracked to we can push it to the remote repositories. What are the remote repositories? So remote repositories are GitHub, Bitbucket, GitLab. So push. So you want to pull the data from the remote repository. Something like yeah, 1 second, I will show you this thing also. So this is your remote repository, local repository. Yeah, save VCS3 file new. Yeah. So this is your so developers. For example, so developers are developing the code, right? These are the developers. Developers are write the code in their PCs, right? Developers are write their code in the PCs. But that code, whatever the developers develop that code, right? For example, these guys are write the programs, these guys are write the programs, these guys are write the programs, right? That code git local repo doesn't know, because of so this is the files you created, but you cannot push it to the local repository, right? How the git local repository knows? So these are the untracked files. These are the tracked files in the local repository. No, these are the untracked files. So untracked to tracked, so we can use the git add command. From untracked to track, it will be tracking and unstaged area. From staged area to we want to push from untracked to tracked and unstaged to stage. Unstaged to stage, so you can use the git commit. Now the file is tracked, the local git repository tracked the file. So what is the file? So this is the file tracked. I want to push this file to the remote repositories. So what are the remote repositories, guys? The remote repositories are, so the remote repositories are, so the remote repositories are, for example, GitHub. So GitHub is the one of the remote repositories. So and GitLab, for example, GitLab. So this is the GitLab, right? Yeah, GitLab is also one of the remote repository. Bitbucket. What is that, guys? Bitbucket. Yeah, for example, so this is the Bitbucket. So Bitbucket also one type of a remote repository. So Bitbucket also, so one type of remote repository. You are pushing the code from your local repository to remote repositories. So what are the remote repositories? Either GitHub or GitLab or Bitbucket. So in the real time, so your companies are using, some companies are using GitHub, some companies are using GitLab, some companies are using Bitbucket, right? The file, whatever the tracked file, the local repository, you can push to the GitHub or Bitbucket, or so what is git push. So you can push to the GitHub account, or you can push to the GitLab, you can push to the Bitbucket, right? So for example, this guy, so this guy also pushed the code. So whatever code, some code, this is the code, this code is pushed to the Bitbucket or GitLab, right? So in your local repository having this code, in our local repository having the this code only, but in our remote repository having the both the code. So this code and this code, this code and this code. So I want to get this code also, whatever the other developer write it and push it to the remote repository, right? I want this code into my local repository. So how you can directly, git pull. So git pull is nothing but a, you will get the, you will download the code. So in your repository, in your local repository, this code is available, and remote repository also this code available, but this code is newly added some other guy. I want a newly added this code into my local repository. You can use the git pull command. So you can use the git pull command. Guys, now you understood? Git pull, git push. The first time you want to clone, so for example, this is my repository. So what is this? So this is my repository. You want to, yeah, so this is my repository. So I pushed the all the code to this my repository, all the code to my repository. I want to get this code to my local repository. How you can get it? So we can use the code. So then you can use the https git. Then you can use the git clone command. For the first time, you can use the git clone command. You can use the git clone command, and you can execute this command. So it will download the, so what is it, guys? It will download the this folder. So it will download the AWS DevOps AWS DevOps material folder. In this material folder, everything will be downloaded from here. So whatever the code is there, right? So whatever the code is there in the this repository, this code will be downloaded. This entire code will be downloaded. So let's check something like let's try, guys. Git bash, git clone, paste. So you guys, everything will be downloading. So receiving the all 621 objects means files. Now check. So what is the file, guys? File name is cd AWS DevOps material. You see, guys, all the files. So whatever the files are there, right, in this. So whatever the files are there in the remote repository, so I downloaded by using the git clone. For the first time, you can use the git clone. Then, so you can add the any file to this local repository. So you see, so this is a AWS DevOps main. The repository name, call it as a main. So what is that repository? The repository is AWS DevOps material. The branch is main. What is the branch, guys? The branch is main branch. Now you understood, guys, the difference between local and remote. The difference between local and remote. So from tracking to untracked to track and staging to unstaged to staging area. So now, right. So the remote repository branches. What are the branches? The branches are called it as a main branch. So main branch, future branch, future branches, main branch and future branches. Let's check it, guys. So I don't want to directly push the data to the main branch. So I want to create another branch. I want to create a new branch. So for example, future branch. So I'm creating a future branch from the main branch, right? So DevOps material, here we have a two branches. One is a main branch, other one is the future branch. So this is also contains the same file. So you can add any file to this future branch and push it to the future branch, and you can merge from future branch to local branch. So merge from future branch to local branch. I will show you, guys. I will show you. Now you understood, right? The Git, how it works. So then how you can install the Git, guys, how you can download it, and how you can install the Git on your local machine. I will show you. So VCS or yeah, guys. So next, so now you understood the difference between VCS and DVCS. Now how to install the Git on, how to install the Git on your local machine. So local mission, for example, Windows. So for example, Windows, you can download it from the download the Git and install the Git. So while installing the Git, it will come Git bash also. It will install the Git bash also. Yeah. So we install the Git bash. So we install the Git bash, and so we can work with the Git bash, and you can install and download the Visual Studio Code. Guys, does anyone knows a Visual Studio Code? Guys, what is Visual Studio Code? Does anyone knows?
Yes, sir.
So what is Visual Studio Code? It's a IDE. Guys, understood? IDE. IDE means Integrated Development Environment. So Integrated Development Environment. So Visual Studio Code. So who developed this Visual Studio Code? So this was developed by the Microsoft, guys. This was a developed by the Microsoft. Visual Studio Code is also a community referred to the VS Code. It is a source code editor. What is that, guys? Source code editor. Source code editor means so how you are writing your Java code, guys. Java code writing through Notepad or Notepad plus plus, right? Notepad plus plus or Eclipse, right? Eclipse, Eclipse. So 2011 we used Eclipse. I don't know. So what you are using, or Atom. So Atom used it, right? So Visual Studio Code is a IDE that was designed by the VS Code. Visual Studio Code is a IDE tool. It's a tool. Uh, if you use the tool, so it automatically, it's a developed environment, right? If you are using the Java, so you can open the open and close braces, right? If you open, like if you open, it automatically open the close braces also, and it will easily figure out the errors where so is there any syntax error, or is there any code error? We can find out easily by using the Visual Studio Code. So Git also, so we can push, we can pull, we can git add, git checkout, or git push, git pull. So we can use the IDE also. So we can use the IDE also, right? So what you need to download? So you can download the git download. So this is the URL, guys. This is the git-sem-dot/downloads. So you want to download for a Mac, or you want to download for a Windows, or you want to download for a Linux. So for Windows, we need a Windows, right? So for Windows, you can use the 64-bit for the Windows setup. 64-bit. Yeah. So let me check control panel. Let's open the git bash, right? Close the git bash. Yeah, guys, one second. I want to uninstall my git. So git. Yeah, I want to uninstall. Yeah, Visual Studio Code. Yeah, uninstall. Yeah, I want to uninstall Visual Studio C++ also, guys. Right, close. Yeah. So I downloaded the git, right? No. Go to the downloads. Go to the downloads. Yeah, git is downloaded. If you double click, it automatically install. Just click yes. Right. Next. Yes. Next. You see, guys, git bash is also installed. So you just next only. So it will install the git, guys. How you can install your git on your Windows machine? You can download from the website for the Windows 64-bit. Then you can double click, it automatically install. Next. It automatically install on the Windows. Right. So once we install the git, so once we install the git, yeah, git is finished, right? Your git is installed. So now check git bash is, yeah, git bash also installed. This is the git bash. Bash is nothing but a born again shell. Same like this is a bash shell. It's working like as a Linux. So whatever the commands, right? The Linux commands will work on the git bash. So we'll work on the git bash. So then you can download the Visual Studio Code. Visual Studio Code download. Go to the Visual Studio Code website. Then you can download for the Windows 11. Right. So Windows 11. Yeah, it's downloading. So downloading, right? So for Visual Studio Code, there is a dependency package we need to download. So that is so VSC++. So 2019 or something, like we need to download these, guys. So this Visual Studio redistributable package, because of, so this is the dependency for the, this is the dependency for the uh, Visual Studio, guys. Visual Studio Code. So want to download. Yeah, guys. So this is the, so latest version you can download from here. Can download from here. So this is the copy link address. So this is the a copy link address for so this is the copy link address for ARM 64-bit, ARM 64-bit. So for example, anything, guys, copy link address and paste it here. So this is the Visual Studio Code. Right, it's downloaded. Yeah. So first we need to install the VC++ guys, because of it is a dependent package for the Visual Studio Code. It is a dependence package for the Visual Studio Code. So then you can install the Visual Studio. Then you can install the Visual Studio. So whatever the code you are writing, right? You are writing on the Visual Studio. So I want to push this code to the local repository, remote repository. I can show you. So I don't want to use the git bash to push the code to the remote repository. So we can use my Visual Studio code and we can push directly from here. So how we can push it, I will show you. So this is the real time example, guys. Okay, now you understood how to install the git, how to install the git, and how to install the Visual Studio code and that VC++, right? So now I will show you a cheat chart, guys. I will show you a cheat chart once again. Mm, yeah, so these are the useful git commands, guys. So useful git commands, you already installed the git, right? So let's check the git version. So what is the command, guys? The command is git git version. Guys, understood? So you installed the git version 2.4.2.45.2. So what is the version? So if the git is working or not, you can check the git command. Yeah, you see? So git command. So if you run the git, it will display the commands. So what are the commands? Start a working area, you can use the git clone a repository into the new directory, clone a remote repository into the new directory, git init, create an empty repository or a reinitialize an existing one. So next, work on the current changes. So git add a file to the index. Move or rename file or directory as symlink. Restore rm, remove the files. So examine, so diff, we are using the diff, guys. Diff log, git diff, the changes between the last commit and this commit. Git log shows the logs, and git branch. So list, create a delete the branches. Git branch, git hyphen branch, git space branch, list the git branches, create a branch or a delete the branch. Git commit, record changes to the repository. Git merge, join two or more development history together. So git rebase, reapplying the commits on top of the another base tip. Reset current head to the specified state. Switch the branches. Tag, create a list, delete, verify the tag objects. So fetch, download the object, refers from the another repository. Git pull, fetch from and integrate with the another repository to the local. Push, update remote refers along with the associated object. So these are the commands we are working in the git, guys. Mostly we are working on the git clone, git init, git add, git diff, git log, git status, git branch, git commit, git merge, git switch, and git fetch, git pull, and git push. So mostly we are using these commands, guys. So I will tell you these commands. So git version, it shows the version of the git installed on your mission. It shows the git installed on your mission. Git init, it will initialize the project folder into the git repository. Git status, it in simple terms, it will show you exactly which files or folders to have been modified. So git add dot, it will add your files into the git staging area. You can also individual files to staging area, for example git add index.html. Git diff, it will show the difference between a file in the staging area and a file that's present in the working tree. So git commit -m, So git commit means it will save your changes into your local repository. It's good practice to include proper commit message, which helps in the debugging. Git push, it will push all the local changes to your you have made to the remote repository, either GitHub repository. Git pull, it will pull all the updated code from remote branch to the merge with your local branch. Git log, it will list down the entire commit history. So git branch in branch name, the command is used to create a new branch in our local git repository. So git branch, it will list down all the local branches that you have created. Git branch -a, it will list down all the branches, that is local branches plus remote branches, that's available for checkout. Git branch -d get name, it will forcefully delete the specified local branch. Git checkout branch name, it is used to switch between local branches. Git stash, it is used to temporarily remove the changes that you have made on the working tree. So git remote, it will give the name of the remote repository, origin or upstream. Git remote -v, it will give the name as well as URL for the remote repository. So remote repository. So tomorrow I will show you guys. So how to clone the repository, how to pull the repository, how to push the repository, git push, git add, git commit, git merge, git branch. Will show you tomorrow. And tomorrow I will show you guys the task is you guys can create your own GitHub, Bitbucket, and GitLab accounts, guys. You guys can create your own GitHub, GitLab, Bitbucket, 3 accounts because of, so everything is same, guys. Everything is same. The sign up is it's a very simple, guys. You guys same like as a Facebook, WhatsApp, right? The same like as a how you can sign up your account. So you guys can sign up GitHub, Bitbucket, and GitLab, guys. You guys can sign up, create a account on GitLab, Bitbucket, and GitHub. I will show you tomorrow how to push the code, how to pull the code, and how to create the branches, how to add the code, how to commit the code, how to merge the code, how to push the code from the Visual Studio also. How to code the, I will show you on the command line as well as I will show it on the Visual Studio Code. For example, you created the programs here. I want to push the code from here only. How you can create the, how you can push the code, I will show you tomorrow, guys. Okay, how we can
Sure.
get that today's class. Yeah, I will upload. Yeah, you guys are yeah, 1 second, guys. So this is my YouTube channel, guys. What it is, so YouTube, so Tech World with Hari, guys. My YouTube channel name is Tech World with Hari. So this is the, so this is my channel, guys. If you guys are not subscribed, you guys can subscribe. In the playlist, I am uploading the, I'm uploading the everyday recordings, guys. The recording is 360-degree Linux AWS Fresher. So this is the playlist, guys. If you open playlist, it will shows all the recordings, whatever the recordings we are posting. So I will post it here, guys. You can, so whoever not subscribed, you guys can subscribe and you will get the notification, guys. Whenever I upload the recording, right, you will get a notifications. Okay. So I'm uploading in the my YouTube channel Tech World with Hari. My YouTube channel name is Tech World with Hari, and I am uploading all the recordings in here. So these all are the playlist, guys. If you want to watch 360-degree Linux AWS watch list, or something like a complete DevOps AWS 0 to Hero or Jan AWS batch. These all are the batches I'm running, and I'm uploading all the recordings into this playlist, guys. Guys, understood? Yeah. And you guys already created your accounts, right? Once you guys created your account, just so I'm uploading the 360-degree DOS freshers, right? I'm uploading the whatever the images, right? So whatever the images, whatever the code I write it, I will upload it in here, guys. So you can check it also here. So the recording also I will upload here. The recording also I will upload every day, so you guys can watch it. So you guys can watch it here also. Okay. So whatever the instruction whatever the images, whatever the text is, and whatever the link I posted here, guys, you can check it in the day 13 or 14. I will ping to Soumya or Vamshi or Rakesh, guys. So you will get it from there. Or else you can directly go to here, 360-degree DOS Linux freshers, and you will search the You will search the a folder, guys. A 14th, I will upload the day 14th. So in that day 14th, I will upload all the details, guys. Okay, guys, understood?
Will it have any storage limitations, sir, in Git repository?
No, guys, you just create your account in the GitHub. So I will give you the link. Once you click the link, it will show you my Git repository. Okay, you don't
Okay, sir.
need a repository or storage.
Means
Okay,
unlimited storage access will be provided. In Git.
unlimited storage access will be provided on the GitHub. You can store any data, you can store anything. Okay.
Multimedia files could also be stored in GitHub,
Yes,
sir.
yes, 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 yes. So tomorrow you will get a good understand. Okay. Okay. Yep.
Okay.
Thank you, guys.
Uh, uh.